Hi, this lesson we will look at Poisson distributions. It is one of the topics from statistics 2. Alright, we will focus on the conditions that we model a Poisson distribution, and once we confirm that this is a Poisson distribution, we will use the formula to find the probability at the end in order to answer the exam questions. Okay, let's see. If an event is randomly scattered in time or space and has mean number of occurrence, lambda, in a given interval of time or space, and x is the random variable, the number of occurrences in the interval, then x is said to have a Poisson distribution and is defined by its parameter lambda. Okay, so this is the way we denote the Poisson distributions. So the conditions are Poisson distributions is suitable model when you have an event that occur randomly, occur singly, occur independently, and occur at a constant average rate in a given interval of space or time. Okay, we will look at some examples later. Then the formula is given in MF19. All right. So another important characteristic that you need to know about Poisson distribution is, can you see that the mean and variance are both lambda? So that means for a Poisson distribution, the mean and variance are same. Okay, so now we look at the examples. So example 1. So situations that are appropriate to be modeled as a Poisson distributions. A. Over a long period of time, a plumber finds that on average, he received 2 emergency calls per week. Okay, first thing, we look at the random variable. So we define the random variable x as number of emergency call per week, right? So according to the conditions we have just now, first thing, we must assume that the calls are randomly. And supposingly, an emergency calls will come randomly, isn't it? And they are supposed to be independently. All right. And then they have to happen singly. What does it mean by singly? It means it cannot occur at the same time, right? The number of emergency calls will come one after the other, isn't it? And there will be a constant rate. So in this case, the constant rate is given by this sentence. On average, he receives 2 emergency calls per week. Okay, hence, this particular situation can be modeled as a Poisson distribution with the mean of 2, right, per week. Okay, now we look at B. A typist makes, on average, 1 error for every 200 keyboard strokes, assuming the errors occur independently and at random. Okay, so it has independently and random. So supposingly, the error will be happening singly, right? So 1 error after the other, and has a constant rate, isn't it? Constant rate is referring to 1 error, on average 1 error for every 200 keyboard strokes, right? So X should be the number of errors per 200 keyboard strokes. Okay, hence X is said to have a Poisson distribution with the mean of 1 for 200 keyboard strokes. Right? So, means when we look at the questions, sometimes it does not mention that this is a Poisson distribution, you have to be able to determine the parameter, which is the mean, the constant rate on your own, and then you can tell what the random variable is. All right, and there is one keywords you can look at, which is this, per week. Per week, or here, for every 200 keyboard strokes, right? According to the definition we discussed just now, in a time or space, right? So these are the small points you can look at in order to determine that this is a Poisson distribution. Now, we look at a partial questions. Right? So this is the questions from May-June 14, paper 7.3, question 7. A lost property office is open 7 days a week. It may be assumed that items are handed in to the office randomly, singly, and independently. Right? Remember the 4 conditions. So it mentions 3 here. So part 1, state another conditions for the number of items handed in to have a Poisson distribution. So to answer part 1, what is the answer? The item handed in at a constant mean rate. Okay, then this particular situations, the number of handed in, number of items handed in will be modeled as a Poisson distribution. Okay, now given that the number of items handed in per week has the distributions, so when you are written, you are given in this form, you know this is a Poisson distribution and the mean 4.0. So now answering part 2. Find the probability that exactly 2 items are handed in on a particular day. So what do we need to determine is, based on the mean rate given, the Poisson distribution, right? The mean is 4, right? So which means we are expecting 4 items in a week, right? Per week, the time interval. But then in order to answer the questions, 2 items handed in on a particular day. So we are expecting the interval to be 1 day. So can you see that? We have to find out the corresponding mean value for 1 day instead of 1 week. Okay, so which means 1 week means 7 days. You are expecting 4 items. 1 day, you should be getting 4 divided by 7 times 1. So it's 407. Hence, number of items per day is a Poisson distribution with the mean 4/7, right, per day. So now only you get to the correct mean value to answer part 2, where the probability that x equals to exactly 2. So 2, okay, according to the formula, which is e to power of lambda, the mean, in this case, the mean is 4/7, and then multiplied with the mean, the lambda, to power of 2 divided by 2 factorial. Okay, then you can press calculator and you will be getting the answer equals to 0.0922. All right. Okay, now we can answer part 3. Find the probability that at least 4 items are handed in during a 10-day period. So again, if one day we expect the handle it item to be 4/7, then in a 10-day period, which is 4/7 times divided by 1 times 10, right? So it's going to be 40/7. So now the random variable is also following Poisson distribution, but it has a mean of 40/7 because it's an interval of 10 days. Okay, so you must be able to determine the correct mean according to the interval given by the questions. Now, only we are able to answer the questions at least 4 items, which means greater and equals to 4, right? So another characteristic of Poisson distribution is, based on what we discussed, X is the number of items handed in, right? In a week or in a day or in 10-day period. Can you see that the number of items handed in, it can be none to many. All right, so for this example, in 10 days, it can have no item handed in, or it can be a lot of items handed in. All right, can you see that from none to many, this is also an important characteristic for a Poisson distribution. So which means if you have question like this, X greater and equals to, you are not able to keep using the formula for like 4, 5, and so on is never ending. Okay, so what can we do is we are taking 1 minus probability of X less than 4. All right, so this is what we are going to do. All right, so what is the probability of X less than 4? Which means we are going to look at probability of X equals to 0, which means no item handed in, or 1, or 2, or 3. Okay, so now we use the formula e to power of negative 40 divided by 7. All right, and for the probability of X equals to 0, 1, 2, and 3, the e to power of negative 40/7 is the same, right? So when I'm trying to write it down, I will factorize it out, and the rest of it, I will write inside the bracket like this. So when the X equals to 0, you are basically going to get 1. Then when the X is 1, then you should be getting this. Right? And then this, the mean, power of 2 divided by 2 factorial. And 40/7 to power of 3 over 3 factorial. All right, then close the bracket. All right, so try to write the calculations in this way. It will be faster. Then the rest of it is using calculator and find out the probability. And you should be getting 0.178577. All right, I round off to 4 decimal places, 1786. And the final answer is 0.821 to 3 significant figures. Okay, so that is how you determine the conditions for a Poisson distribution, and use the mean value given to find out the probability according to the interval given. All right, that's all for this lesson. I'll see you in the next video. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.